Okay, question number 3. A medical researcher surveyed a large group of men and women about whether they take medicine as prescribed. The responses were categorized as never, sometimes, or always. The relative frequency of each category is shown in the table below. Alright, so question A. One person from those surveyed will be selected at random. What is the probability that the person selected will be someone whose response is never and who is a woman? So never and a woman. This one's pretty straightforward. It is literally just that. So 0.0636. You should be able to just write that down and be fine. So let's do that real quick. I 0.0636. Okay. For A2, what is the probability that the person selected will be someone whose response is never or who is a woman? Okay, so we have a couple of things going on. We want never or a woman. So basically, what we want are all of these. There's a couple ways to get them. You can just add those 4 numbers. That will certainly work. You can take 0.53 plus the 0.0564. Or, so the formula way to do it is add those two. Add the 0.53 and the 0.12, and then subtract the 0.0636. It doesn't really matter what you do, but you should do one of those, and you should show that you have done it. So I'm just going to write down all the stuff. 0.0564 plus 0.0636 plus 0.1384 plus 0.3280. And whatever that adds up to. Alright, for part 3, what is the probability that the person selected will be someone whose response is never, given that that person is a woman? Alright, here we are only looking at women. We're just looking at this row right here. What is the probability that they will respond never, given that they're a woman? So essentially, imagine that we have 53 women total. 6.36 of them answered never, 13.84 of them answered sometimes, and 32.8 of them answered always. How do we find that probability? It'll be 0.063 out of 0.53. So, for 3, we'll have 0.0636 over 0.5300. For the people surveyed, are the events of being a person whose response is never and being a woman independent? There are a couple different ways to look at this. So this is only asking about never and women. It's not asking, are these two things independent, because these two things are not independent. If we calculated more probabilities, we would see that. But what we want to do here is look at deconditional probabilities. Two things will be independent. B will be independent if the probability of a woman given never is the same as the probability of a woman, or the probability of never given a woman is equal to the probability of never. And so just calculate one of those. This is what we did in part 3. That is that calculation. 0.0636 divided by 0.53, that is 0.12. And the probability that never is also 0.12, right? So those two are equal. So yes, independent. Again, we're just looking at those two. If you go further into the other stuff, this sometimes is not independent of gender, but never is independent of gender. So that's as far as we have to go. All right. Assume that in a large population, the probability that a person will always take medicine as prescribed is 0.54. So basically, we're assuming that this is true. If 5 people are selected at random from the population, what is the probability that at least 4 of the people selected will always take medicine as prescribed? Support your answer. Okay. So what do we have? We just have the 0.54. And we want at least 4 out of 5 successes. Okay, this is a binomial model. Trials with 5 trials, and the probability of success equal to 0.54. And we need successes greater than or equal to 4 is what we're looking for. All right, so there are a number of ways to do this. Those are all of our possibilities. That's what we're interested in. That's what we're not interested in. You could certainly just find this probability and find that probability. That would work. This one is going to be the easy one. This one is going to be a little trickier because reasons. So if we look at the formula sheet, binomial distribution is right here. Ugh. Yeah, drawn on the computer's weird. That's our binomial distribution, right? So n choose k, p to the k, 1 minus p to the n minus k. You could write this down. It's like n is the number of trials, p is the probability of a success. We've given those already. And then k is either 4 or 5. So we could certainly just write that down. We could go, this is 5 choose 4, 0.54 to the number of successes, 1 minus p to the number of failures, and then add it to this one, that's 5 choose 5, not divided by 5 choose 5, 0.54 to the 5th. You could put 0.46 to the 0th if you wanted. That would work. You don't honestly, like, they're not requiring you to go all the way through in your computations, from what I understand. So if you want to leave it like that, that is fine. The other way, that is probably the more normal way, is to use binomial CDF to find that, and then take 1 minus that to find what we're actually interested in. So it's going to be 1 minus binomial CDF of some stuff. So now the problem comes in that you've forgotten how to do this. This is where the test being open internet, or actually, like, have this stuff on your formula sheet, right? Like, you should have binomial CDF, trials probability value, written somewhere, like, right next to this on your formula sheet. Because, you know, you've been doing that all year long, and so since it's open note this year, you know, you can take advantage of that. But if it is open internet, this is the kind of thing that is good, actually good to look up, how to do specific things. If you're trying to look up, how do I do a t-test, you're in trouble. If you're trying to look up, what's the syntax for binomial PDF, you're fine. Like, that's a thing you can look up quickly. Anyways, trials probability value. All right, so they don't, on the AP test, accept calculator syntax unless you are explaining it. So if we do 5.54 and 3, we need to explain what each of these numbers are. This is the number of trials. This is the probability of success. And this is the upper bound. If you write that in there, you will get full credit. If you do not write that in there, you will get 0. So explain, if you are using calculator syntax, you need to explain what each of the things are. If you're trying to do this by text, like you're typing your responses, you aren't handwriting them, write like 1 minus binom CDF trials equals 5, P equals 0.54, upper bound equals 3. That will work if you all just want to do it in one line. Otherwise, the arrows and everything is, I don't know, a little more explanatory. But yeah, that is question number 3.